Hello, welcome back. I hope you've all had a great lunch. We're on to our next session now on the observability and security stream. And we've got introducing OWASP wrong secrets, how you should not handle your secrets. I'm really looking forward to this one. This whole secrets management, the topic that for many of my CTO gigs has kept me awake at night when developers told me how they were actually storing them as opposed to what they told the security auditor. Jeroen is going to take us through OWASP wrong secrets. Hadn't come across this before, and it actually sounds like fun. So I'm really looking forward to Jeroen telling us more. Away.
All right, thank you very much for this very warm introduction. So let's get started. Um, so here we go. Camera, action, go! Awesome. Hi everybody. Jeroen Willemsen here, project leader of All Wrong Secrets, and today we'd like to talk about secrets management. We got a little poll in the background going on. Feel free to to give feedback because what I'm really looking forward is understanding like, hey, where do you store your secrets at? So let's get started. A little bit about me. So I'm Jeroen Willemsen. Like I said, project leader of WrongSecrets. I can put a lot of contact details in, but you could also just follow this link and find different places where we publish about the project, publish about the stuff that we do, and we can have a chat later on, basically. For now, the most important question, which indeed have kept many people awake. So again, thank you so much for the introduction, Finbar, is can you keep a secret? So can you keep a secret is actually a question you already get exposed to as a human being far before you touch computers. Remember when you played around with friends and you had this actual little secret, giggly giggly? Were you able to keep it then? Were you able to not share that with others? Um, that's actually a very important question. Whole kingdoms have been built on trust, on the idea that certain secrets were never shared, and when they were, we got in trouble. So then you might ask yourself, can you also make a computer keep a secret in such a way that, nobody else is going to see it? Well, that's going to be pretty daunting. And that's where this session will be about, of course. But before we get a feeling for what a secret is, let's run through examples. So everybody by now can tell, credentials. Those are we should keep those secret. Makes sense, right? Um, but let's go a little bit further. How about your OTPs? How about your private keys or HMAC keys used to check integrity of messages? How about the TLS private keys or your IAM access keys for your cloud environment? And then slowly, more and more things will pop in your mind if you start thinking about is what should be a secret? What is your secret? What shouldn't you be sharing with others? And what should your computer definitely not leak to somebody else? All right. Well, now that we have a little bit of a feeling what secrets might be, let's move a little bit further. Where would you store a secret when you would be in running something in Kubernetes? You could also say Nomad, of course, or any other runtime environment where you drop your containers or your workloads. But would you store it in code? Hopefully not. Well, maybe in a container. Feel free, by the way, to enter the poll so we can see what you have been using so far. Or you use Kubernetes config maps or Kubernetes secrets, or do you actually have a secret manager? Or do you use your cloud solution, like your platform providing solution, like AWS Secrets Manager, Azure Key Vault, or all sorts of things? And then, of course, there are so many other things your organization might be providing, something like HashiCorp Vault or another a likely secrets manager, or you actually just put everything in your password managers and share that across your organization. There's so many places where you could possibly store your secret and then expose it back into a Kubernetes cluster into your own runtime. Not all of them are easy to use, but some of them might have some drawbacks. Um, let's see if some of you actually filled in the poll. That's interesting. So in the results, we see people actually that it was stored in code. Basically, almost everything was touched but the Docker container. Well, that's interesting. Let's see how we move ahead with that. Um, so the next question will be, let's assume you're compromised, and that will be my next poll. Uh, do you know where your secrets are? At this very point in time, you'll be called by one of your security team lads or ladies, or you'll be called by your CTO, telling, "Hey, I got this call. We're compromised. We're in big trouble now. We need to rotate our secrets. Do you know where your secrets are? And do you know what the purpose is? So if you rotate them, what should break? What should be updated? And can you actually rotate them timely?" Um, That's actually already becoming pretty daunting, isn't it? Because do you actually know the purpose of that thing password that Joe from Tmax lately uploaded to the secrets manager? Well, I see tons of passwords now. I have no clue where to look for anymore. Um, okay, so far everybody said yes, we know where all the secrets are. That's good. That's good. Let's move a little further. Um, if you go to another perspective, can you tell us, for instance, when your secret was last borrowed by your ex-colleague, aka when somebody actually touched the secret? And so do you know when your secret got leaked to another place? And can you tell also when your secret was no longer working anymore? So the last one is often something that people do very well. I mean, an application possibly breaks if it can no longer authenticate towards another API, right? Because then you see these stack traces or error messages, and we know, okay, something is broken. We need to do something about it. But if it comes to basically monitoring your secrets, whether they're used in the way they're supposed to be used and not accessed by anybody else, that can be a bit harder. Um, so, for instance, what we sometimes end up with is that people start monitoring the secrets and that they want to have an alert when it's grabbed by something else than the recommended IP address from which request towards the secrets manager can be done. And then the entry should be logged. And then sometimes we end up with also including secrets while logging about it. Okay. Um, so apparently, secret management is special, as in we can make lots of mistakes. It can become rather complicated. But given that we already get a spread out of answers on where secrets are being stored, it might be very interesting to see how that moves ahead. Um, and therefore, we created OWASP WrongSecrets. Now, let's dig in a little bit for about half an hour into the project, and we'll do that as follows. First, we'll talk a little bit about the project itself, then I'll show a little Docker demo on Heroku, which is live. So, if anything breaks, apologize. Feel free also to play along with me by visiting the same URL, and we can have fun. Then I'll show a little bit of an AWS demo. Then we'll do a few takeaways about what you could learn from this project and what will be next for this project. All right. Um, feel free to, by the way, use the chat to give any feedback or any questions, so we can have a chat about it. All right. Good. So what is OWASP WrongSecrets? It's a vulnerable app, and it's also a secret detector testbed. And we'll get back to that later, basically. It's an OWASP lab project, which basically means it has the status where the OWASP organization says, hey, we really see value in the project, now move, make it even cooler. The goals for it are basic of our project are is to educate people on secret management and its pitfalls. So you really, when you play around with the app, get a feeling for, hey, what should I look out for? And also, while you play with that, we hope you will be reflecting on your own secrets management strategy. Because I'm sure everybody by now said, hey, we didn't put any of our secrets in a container. At least that's what the poll is telling. Unfortunately, in public registries, we still see about 70% of the containers containing actual secrets. Not replacements to be replaced, but actual secrets. And last but not least, we want to promote secrets management as an important facet of security. Basically, what we often see is that how you do secrets management nicely reflects the maturity of your information security program within the organization. But we'll get back to that later a little bit. Of course, it's an OWASP project, so we do this all on voluntarily basis. Therefore, a huge shout out to my co-leader Ben De Haan. Thank you so much for all the awesome work you've been doing so far, but also to all other contributors, testers, and people that helped us out throughout the process. All these people made this project together, and we wouldn't be here presenting this without them. So let's dive in. What does this entail then? So the overall architecture looks as follows. It's basically at this point in time, it's a Spring Boot application in Java 18 with some Spring configuration. All of that lands into a Docker container with a bunch of additional things to show what you shouldn't be doing with Docker containers. And then you can either run it directly on Heroku, which we'll demo later, or you run it as a pod on Kubernetes. Then next to that, on the same Kubernetes cluster, you'll find Vault and Console, so we can have fun with a typical secrets management solution for you. And then either you run it on Minikube, so you can run it locally, or you can deploy it to AWS, GCP, or Azure, for which we included Terraform code. So it's all in there. You don't have to do configuration yourself, other than authenticating yourself and making sure you have the rights to deploy to your own cloud environment, and you can have a go with this. So that's enough talking, I guess. Let's start with a little bit of a demo on the on Heroku. So if you go to wrongsecrets.herokuapp.com, you'll basically end up over here. Now, this is in the Heroku free dyno, so every time you go here, if nobody else is using it, it might take about 45 seconds to warm up, start up, and get the application in there. Here you can see a bunch of challenges the system currently contains, and all the Docker challenges are accessible. And later on in the AWS demo, you'll see that everything is accessible because the cloud environment, well, you need a cloud environment to do cloud environment demos. Let's start with a very simple exercise to get a bit of a feeling of what this whole system is about. So, challenge number one. I think we all have been here. At least I have been here as a developer. When you try to prototype a certain application, try to make that work, you might not always take the time to diligently move away any secrets from your code and, put it in the right places within the organization, but just quickly, type in some authentication materials or credentials to make sure that a certain client can connect to an API so you can show your proof of concept. So that's all good as long as you don't do git commit, git push. But what if you forget to remove these hard-coded secrets? Then what? So then the question is, can you spot the secret we are looking for in the code? And what about looking for it in the container? And we're looking for a password. Now, there's a bunch of ways how this project can help you. So first of all, this can be a nice hacking challenge for you. So if you're in security and you feel like, hey, I don't need more tips, let me add it, you'll be able to find it easily. If you feel more like, okay, make me understand how to find this, then there's certain ways how we can try to detect this. And this is where the show hints come into play. So if you follow this lead, basically, it will be fairly easy to find your way, basically. And what we're going to
Jeroen?
do is, yes.
Sorry, Jeroen, can we just double
Oh,
check? I don't know if you're showing a link on the screen at the moment, but we can't see that.
apologies. Let me see, something is going wrong with the sharing options. Thank you so much for showing for mentioning it to me. Let's try this one then. Can you now see my screen?
Brilliant. Oh, we have it. It's got multiple layers.
Exactly. So
That's
going
it.
back. So
Brilliant. Thank you.
basically wrongsecrets.herokuapp.com. Apologies for the wrong sharing. Over here you basically see the challenges like I told. So in this Heroku environment, which is basically a Docker container, you only see the Docker challenges. But of course, once we do the AWS environment challenge, you'll see all the challenges lighting up that you can play around with them. So let's start with challenge. Let's start simple with challenge number one, which is about the hard coding content. So here it's the password we're looking for. Apologies for not showing, but like I told earlier, you can now start using this as a starting point for you as a security specialist. But if you feel more like just show me how to find this in my own organization, you could just click the show hints button and you'll find multiple ways on how you possibly would be able to basically find secrets within either Git or within a Docker container containing that secret. Let's try to follow this one. So we already cloned our environment or cloned the repository locally, and now all we have to do is basically make sure that we can start looking for the secret. So this is something you can do anywhere. First, you install Git secrets, so it's not an extension of Git, but Git-secrets. Then, if we go over here and we say, let's add the detector, and we now say Git secrets -- scan, then we'll see a bunch of items coming by. So let's see where we can find our. So it might be easier if we say something like grab password, because then we're really sure what we're looking for. And then we should be able, as you can tell by now, we put many different things in many different locations. But this was, of course, in a Java container or in the Java code. So here you see a Java file, which is constants.java, and it has a public static final string called password. With its value, default login password do not change. Now, before you think this is all preset, like, this is a runbook I'm running, are you real? Let's see if it takes any other answers. Well, that's perfectly wrong. So let's just give the right answer. And as you see, it's now correct. So what we just learned by this is that you now can start checking your own code with tools like its secrets. Think about the typical variable naming that you would have been using or your colleagues would have been using, and you can start scanning various repositories for secrets. Similarly, you can do stuff like trufflehawk3 and other type of tools that will actually give you a similar result. I think that will be something we'll be doing in the next challenge. So let's go to the next challenge. So the next challenge is basically a little bit different. So some people say, hey, hard coding in code is wrong. Let's put it in the configuration because that's not hard coding, is it? Well, I hope by now you realize that that's actually something similar. So let's see. So in number 2, there's application or properties of the Spring Boot application, where you might end up with having secrets. So again, we have the hints part. We can use Trufflehawk or something else, or you can just directly look at application or properties. And what we're basically looking for is a given secret. Shall we have a dive in there? So I already opened my IDE just to make sure. And then here we have our application or properties. But before we actually go into the rest, let's dive into the project so you can get a feeling for what we're looking for. So challenges over here are organized in different types, like cloud challenges, Docker challenges, and Kubernetes challenges. And challenge number 2 is over here. So now you know that we're looking for a password, like over here, the Spring Boot injected password. So if we now start looking for password, then this might possibly be our password variable. By the way, it's not a bad practice to have placeholders in your configuration, which you can later on override. But the interesting part is that we often forget to override them and then sometimes end up with the placeholder becoming the actual secrets upon first registration, for instance. So it's always good to check your configuration in that sense. Now let's see if this is correct. Yes, that's actually correct. All right, so code is not really a good idea, is it now? Let's move ahead in the third challenge. So the third challenge is about Docker containers. So I guess we all, like we already saw in the poll, did see stuff in environment variables, but we could also put that in Docker environment variables. So what if we just had it hard-coded in the Docker env variable by itself? So let's look at our Docker file, how we basically create our materials. Going over here. Here you can see the Docker file of the project, which is also just on Git. And then over there you can see that we have an env, Docker env password. This is it. Okay. Well, that might be very much it. So let's try that out. Yeah, it actually is. So of course by now you probably would say, nah, I'll never put it in an environment variable. Everybody can see that. It's right in the registry. It's right in the Docker file. Nobody does that. No, what you should have done, Mr. Willemsen, is use args. Should I? Let's have a look on our fourth challenge. Let's use a Docker arg password. So Spring configuration nicely became a placeholder, and Docker args are being used to override the value. And now the question is, of course, okay, can or can you not spot it? And here is where Docker Hub can come into play, or various other ways of doing this. So if you just look at the show hints, you can also do this locally with Docker history. But you can also just go to Docker Hub and find the actual env, or you can just do Docker inspect and see what you find over there. So let's try to find the arg-based password. Let's try to find that one first. And that's basically by Docker. So this, and then the tag number, and that will be 141, because that's the version we're running at. That's what you can see over here, version 141. So let's try to do that for a while, shall we? 1.4.1. Let's see what we end up with. Oh, no such image. Wrong secrets. And here's the demo bots playing around with us. Let's try to Docker images. Maybe we can use another one. Yeah, let's use just the latest over here, because this is actually doing the same thing for now. Normally you would just do Docker when you get it, but let's do this. History latest. And now you should be able, let's make this a little bit broader and run it again. Now you should be able to actually see the different things happening. So there is a bunch of env set, then there's an arg-based password being set, and then Over here is an arg-based password, hello Java 18, but it's truncated. Maybe we should say no trunk. Here we are, sorry, no trunk, so we don't truncate the screen. And now we move it ahead, and now it becomes a little bit harder to read. Let's see if we can make that work a bit. And then let's go over it. So as you can tell, different commands are over here. So in every layer, they just do different things. And then over here, the env arg-based password is where the arg value is being assigned to an environment so we can actually use it. And this seemed to be our password. Okay, let's give that a shot. Okay, so apparently, even if you use args, it's not a good idea either, because you can still easily find it back into your layers. And you might think nobody makes this mistake, but this is actually something we've detected far more often in existing containers in private registries, but also in public registries, unfortunately, when we did try to do some verification of infrastructure or do some pen testing with certain customers, for instance. So, okay, apparently that's not that good. So, going back, apologies for this. Let me see. So yeah, going back again to the home screen over here, there's a bunch of more challenges you could play around. For instance, think about one-time generated passwords that are ending up in logs, which you can find, for instance, challenge 8. But also think about things like having password managers or secret managers with low entropy passwords, which is also one of the Docker challenges, and we'll have many, many more inside. So I would suggest, if you're watching this, or if you feel like watching this later as a recording, feel free to jump in on Heroku and just have a go, and see what you can find in a Docker level. So that's all good and all fun and games. But maybe it's already interesting to start having a look at the next level. So let's go one level deeper. So what instead if we take a look at AWS? So like I told earlier, we have support for AWS, Azure, and GCP. And to show how that basically works is if I collapse everything in my project. I hope you can still let me share my screen, like the right screen. Again, apologies for the jumping back and forth. So if you take a look at, I hope it's readable. If you take a look at the project structure, basically we have an AWS folder, an Azure folder, and a GCP folder. Each of those folders contain all the instructions you require to basically apply the Terraform by just following these steps and then running a bunch of scripts to make sure that the EKS gets filled up with the right containers and the right servers and all the other jazz, so you can play around with it. So I already did this for you yesterday evening to spin everything up so we can tear it down at the end of the day again. Feel free until then to play around a bit if the URL is repeatable, basically, and then you end up in. So this is the most simplest setup you could possibly have with a simple ALB controller and a simple domain assigned to it, all automatically generated. And by now you can tell you can do all the challenges out there. So I don't know about you, but many people have always, pushed for instance, having infrastructure as code. Infrastructure as code, as the Terraform, for instance, used in this project, is wonderful because it gives you a clear direction. It becomes very repeatable. You can easily tear stuff down or spin stuff up. You can actually check the code before you run it to see if you do anything that might introduce a vulnerability into your cloud configuration. So that's beautiful. But for this one, it's a bit interesting because the Terraform is basically storing the reflected state of the cloud or the reflected state of the things that it talked to through a Terraform provider in Terraform state. Now, there are Terraform state providers that can help you to create secrets, but unfortunately, they will also store that in the Terraform state. Okay, let's have a look, shall we? So over here, like I said, I have my AWS folder. I did Terraform apply over there, and I ended up with something called Terraform state. The Terraform state basically keeps a lot of different things. There's like There's parameters for the parameter store. There's your IAM setup is settled over here, so stuff like this. So metadata about it, the availability zones that we're using. So Terraform state really stores everything. Now, the problem basically is that next to, so you can see the policy documents, for instance, being stored over there. But the problem is, of course, that if we now start having things like managed AWS secrets manager secret, apparently we can also have other stuff in there. So here we see properties for a given secret or a secret reference. So now looking at, for instance, this one is a random password being generated by the Terraform, which is done throughout this provider, but we forgot to protect it. So now we end up with apparently some sort of secret inner Terraform state. Okay, well that's weird. Let's see if that actually is the one we're looking for. As you can tell, the score bar started over again because we're doing this in a different environment. If you submit that, yeah, apparently that's correct. So what you can learn from this is once you basically take a look at your Terraform state, is that there can always be secrets inside. So be very careful with how you handle secrets of infrastructure as code, because apparently you can easily make boo-boos over there. Let's move back. So that's a few quick demos on how our project offers you various challenges to get a feeling for what is happening. If we have time left for Q&A, we could also jump into a few more demos to see other things from similar angles. And again, if you have any questions about it, just enter it in the chat and we can have a talk about it. So then the big question becomes, so how should we do it, right? I mean, it's fun to know how not to do it, and these challenges will help you to see what you have to look for in order to find secrets that are stored wrongly. But then the question becomes, how should we then do it instead? For that, there's a bunch of things also included in our project, which you can see on the Heroku app. If you go to the index of the project and you scroll down, you end up with these links. A top 10 points on secrets managers, the OWASP SAM definitions on secret management. If you're not familiar with OWASP SAM or OpenSAM, please have a look at the project. It can give you great guidance on many things within the SDLC in general, and it also will help you in terms of secrets management. And then, of course, just take a look at the secret detection topic at GitHub. You'll find tons of tooling and tons of ideas and things that are good to keep in mind when you start working on it. And last but not least, have a look at the OWASP secret management cheat sheet. This cheat sheet is created by various volunteers and is maintained by OWASP currently. That can give you a lot of do's and don'ts, and especially do's if it comes to using your secrets in CI/CD environments and all other sort of things. Last but not least, I'm pretty sure that by now you start thinking of, hey, but shouldn't we be able to detect these secrets up front, right? I mean, if we run it in the pipeline or run some local tooling, because you just played with Git secrets, you talked about TruffleHawk. So there's many different secret detector tools out there. And what can really help you is try to use all WrongSecrets as a secret detector benchmark. So when a vendor comes up to you and say, hey, it's awesome you are worried about secrets management. I got this awesome tool with which we can detect all the secrets in your code. Use our project. There is a bunch of instructions in an issue together with a branch that is specifically created to make sure that there's tons of different secrets inside, and it's always growing. And if you feel like, hey, there's multiple secrets missing, just let us know, either via an issue in GitHub or something, or Slack or email, and we'll add them for you. Without telling that you were the one asking, if you want to do this anonymously. Otherwise, celebrate the collaboration between you and us, like we're already doing for all the other people that have contributed to the project. And then basically we can grow the benchmark. And then when you want to make sure that your tool is up to par to detect the secrets that you're worried about, use the project. So that's a bit on how to do it. So let's take a few takeaways. So first of all, never hard code anywhere. And second, don't just trust defaults, because if you take the default configuration of, for instance, the password generator that we used for the infrastructure as code, you end up with something that is not obfuscated or encrypted. So it's going to be pretty hard to secure that. And also another thing is, by now, make sure you can rotate your secrets, or rather use ephemeral secrets, because the shorter the secrets live, the better it is. And by now, I think you probably realize that it's going to be pretty hard to store a proper secret in the system, to store a secret in a system properly. And because of that, it's very important to think about blast radius reduction. So to make sure that whenever a secret is obtained, that it's not some secret that can be used everywhere, but that it has really a small scope within a certain API to be used, but not everywhere at the same time with high-end privileges, because otherwise you end up in trouble. Next, make sure you reduce exposure. Most of the places within our challenges you'll see are basically easy to find, easy to access. So make sure that you in such a way that it's hard to get there and that you really need to be authorized to see it and not authorized by default. And last but not least, have logging and alerting in place. Whether it's about when your secret is being touched, or whether it's about when your secret is consumed, so that at the consuming side of things, you can tell, okay, I got in trouble because our secret is now used by not by our normal data center in the EU, but all of a sudden it's used from Russia, China, Japan, and the US. Well, by then we know that secret's possibly no longer safe. Where do we go from here? So, well, luckily we just moved to a Java 18, so that was done just 2 days before, or finalized 2 days before this slide was uploaded. Apologies. And of course, we want to improve the development of the tool. So when you want to join us to create more secrets or more secret challenges, basically, we're trying to make it easier for you to develop that. The next thing that we'll be working on is secret hiding in binaries, because there's unfortunately still a firm belief of many people that if it's in something that is compiled toward machine code, it will be very hard to find. For those who are unaware of the tool, try to load a binary in GHydra and see if you can actually see what's happening. And with a few YouTube instruction videos, it shouldn't be too hard for you to already dissect quite a few and see who else made the, well, wrong assumption that you wouldn't be able to find the secret inside. And of course, we're trying to look at other challenges and mistakes spotted in the wild. Next to that, we want to work on stuff like CTFD, UI improvements, and extend the secret detection testbed, and many more of these items. So yeah, if you, of course, you can really use your help at this project. So if you can, just take a look at our GitHub, promote it if you like it by giving it a star, just by showing your support, because that hugely motivates us, as in all the volunteers, to work at it. Take a project for a spin, just to see if it works for you or not, and give feedback. That can be done in various ways. You can file an issue, you can contact us as OWASP Slack, through OWASP Slack, or through other channels. And if you feel like, hey, but I would love to contribute, just file a PR. There's enough instructions in the README to get you started. If you have any questions or you're not really sure about how to progress, just contact us, then we can do it together. And in the end, we'll make sure you get listed as part of the volunteers, basically. And that actually concludes my session, a little bit shorter than expected. Thank you very much. Do you have questions?
Excellent session, Jeroen. Thank you very much indeed. I love how you presented us with live examples there. So you're certainly today's bravest speaker, that's for sure. And I think that's always, that's true kudos to you for that. That's really a man who knows what he's doing. So that was fascinating. I love how this project has gamified what can be quite a dry topic. I mean, that genuinely looks like fun, So, I mean, what a great initiative. I don't know. Are other OWASP initiatives looking at that and thinking maybe we need to gamify what we do? I think it's a great approach. But yeah, just in terms of, I don't know if we're getting any questions through on the online channel here, but just before we get any there, I'd be kind of interested in, what's your experiences in teams? This is a great approach to get people familiar with OWASP topics. I've not always seen great consistency there, so I've seen some teams really adopt it. I've seen other teams kind of ignore, and other teams actually resist it on the assumption it's gonna slow them down. I mean, what's your experience in terms of maybe the wrong assumptions that people might make? You know, what can be the wrong ways of looking at it, if you like? Well, you know, how have you seen, you know, people struggle with this, and what should we be considering instead?
Yeah, so there's first of all, like many topics that OWASP tries to pay attention to, secrets management is hugely opinionated, unfortunately. It really depends on the angle you're looking at it, and there's different ways to solve problems. Um,
Hmm.
so one big struggle is where to store the secret, and when do you do this right, or when is it wrong? Should people have access to it or not at all? Who should be able to do break glass? And there's tons of these sort of things. But one of the very opinionated things we see a lot more nowadays, which is also has to do with code quality and other things, is where should we start detecting this?
Hmm.
So the ugliest part, what I end up in discussions with many people is when are we too late to detect it? So,
Oh.
for instance, you could have a secrets detector running in a pipeline, right?
Hmm.
Saying, hey, this code, that's a secret, all right, that's a valid key, or hey, we checked this AWS contentious, there's no placeholder because we can just access stuff. Stop doing this. But by then, it's already in the code. So, of
Yeah.
course, you can then say, oh, but at least we know. So now we can rotate. Um, but that means you should also rotate, and that's not always happening. So some people stood up and say, we got this covered. Let's do a pre-commit hook, right? Because then before we start committing code, we can start detecting stuff. But that's awfully hard because
Hmm.
what if something is not a secret and the detector keeps on saying, can't commit? Well, that's hugely annoying. So you can't get your code committed while the building is on fire. You need to walk away from your laptop. You know, those sort of emotions start popping up. So where do you do it and how do you do it? It's hugely opinionated and it's very hard to crack that nut. I don't
Hmm.
think there's a wrong for real, as long as you rotate eventually. But again, it's an opinionated subject, and everybody might have its own opinion ways of working, as long as you end up making sure that the new secret is secure timely, basically.
Hmm. Brilliant. No, great stuff. Thank you. And in terms of, you know, I love the Heroku site, and again, it's so useful. It looks like there's some fabulous resources on there. Where else would you direct people to if they're wanting to learn more about this?
So once you jump into this secrets management cheat sheet, for instance, from OWASP, you'll end up with a bunch of links as well into other
Yeah,
directions.
brilliant.
Then there's also NIST standards that can greatly help you on certain attributes of secrets, and there's, for instance, the key length finder that can help you on certain cryptographic guidelines on what to use and when to use it to protect certain secrets. And from there onward, it's really about what will help you. That
Yeah.
sounds strange. I can define you what you have to do, and it's secure, or secure enough. The residual risk will be low enough to work because it's never secure, right? It's always
Hmm.
just something we should be able to work with. But that might not work for you, and that's a bit of a silly answer. But from there onward, just experiment and try to find what works for you. Whether you want to work with your cloud vendor secrets management infrastructure,
Hmm.
or you like to use stuff like HashiCorp Vault or other type of secrets managers, or you go all the way back and say, hey, we got this stuff running on Nomad.
Yeah.
Let's use Nomad secrets. But then again, please make sure you read upon whatever that given tool that you like supplies you with guidelines.
Hmm.
And the RTFM part is very hard in our way of work, in our line of work, because there's
Yeah.
too many manuals to go through.
Yeah.
Um, but really, don't skip this. That's
Yeah.
really a takeaway for that one.
No, brilliant. Thank you. And I think, you know, that's what it just comes across so strongly in this project, that really there are few excuses, I think, for people getting up to speed with this. It's like, how can we make it? We couldn't possibly make it easier, and it's such a fun way of picking this up. And then I love the contribution. You know, inviting those contributions and spreading the knowledge base is so powerful. So, yeah, again, Jeroen, thank you very much. Excellent session. We're well under, but it looks like people are content with that. We've got some good feedback through. I hope people follow all of those links. But meanwhile, thank you very much for that, Jeroen. Thank you.
All right. Thank you so much for having me here, and have a great day for the next awesome sessions.